It is a battle that takes place in homes and offices around the world as people tussle over the thermostat to find the right temperature. Now researchers have discovered a gene that plays a key role in the ability of mammals to determine if they are too hot or too cold. The gene, which produces a protein called TRPM2, sends a warm signal that drives mice, and other mammals, to seek out cooler environments. Mice that lack this gene are no longer able to distinguish between cool and warm temperatures. It raises the prospect that the gene could help explain why some people find a room uncomfortably warm while others will find it too cold. Professor Peter McNaughton, a biochemist at King's College London, told Mail Online, "There are variations in heat sensation between people. Most notably, women tend to prefer a warmer temperature than men, which can lead to problems in designing buildings. We are interested in finding out if the difference in thermal sensation between men and women is influenced by the TRPM2 gene, but we don't have any data on this just yet. The temperatures we examined are certainly comparable to those you might find on a London bus or tube carriage in the height of summer. At 38 degrees Celsius a busy tube carriage would be quite suffocating, so sensory neurons in our skin allow us to detect that the environment is too warm and drive us to take action, whether that be removing an article of clothing or lighting the tube and seeking a cooler environment. The TRPM2 protein forms a channel that can allow positively charged ions to enter and leave nerve cells, altering its internal voltage. This change in voltage triggers nerve activity, creating a sensation that is detected by the brain. Other proteins in the TRP family are known to be involved in detecting painful levels of heat. But the researchers, whose work is published in the journal Nature, found that when they engineered mice so they lacked the TRPM2 gene, these mice were no longer able to detect lower levels of heat. Normal mice walking across surfaces warmed to 91.4 degrees Fahrenheit and 100.4 degrees Fahrenheit tended to prefer the cooler temperature, but the mice lacking the TRPM2 gene did not have a preference. Dr. Chunjiang Dan, another member of the research team at King's College London, said, "The removal of TRPM2 in these mice eliminated their ability to detect non-painful warmth, yet the capacity to detect painful levels of heat using other known receptors was unaffected. This reveals how we are able to detect environments that are too warm at a sensory level." The researchers now hope to find out whether the protein may also help the body regulate its temperature in an unconscious way too. Professor McNaughton said, "From a practical point of view, gene defects in humans may lead to defects in warmth sensation, though once again we don't have any direct evidence of this. We have shown that TRPM2 is important for the conscious detection of warmth, but does it also play a role in the unconscious regulation of body temperature? In future studies it would be interesting to explore whether TRPM2 also plays an unconscious role in controlling our body temperature, by regulating sweating and the constriction of blood vessels in the skin."